All right, welcome back. In this lecture, we're going to continue on building out our password rules, and we're going to introduce some new types. And one of the things I want to start off with is the idea of a sequence, and that strings are actually just sequences of characters. So if we take this, let A equal this is a string. We now have a string called A. We can call sequence.toList on A, and we will get a list of characters that represents that string out of that. And so what is a sequence? Well, sequence here with a capital S is a module that contains all of the sequence functions and types. And this is one of the ways of building a sequence. This is actually what's called a computation expression. We'll eventually get into what computation expressions are and how to use them. But if we run this, you see that it printed out just part of it. This is THIS ... Right from that string. We just iterated through that string and we're yielding out. So this is a for loop, right? For I in A. A is this string. It's going to pull out each character into I and yield an I into this sequence. Sequences are computed, so we can do a variety of things with them. We can say for I in 1 ... 1000 do yield I. And here's that's 100. So here's a sequence of digits. We could say something like let B equal that sequence. So now we get B as this sequence of integers. And we can then take that and use sequence.toList B. And we'll see now we've got the full list. So this is a computed set of values, and it's yielding them back. So it's sort of like an iterator or an enumerable type in a way. It's just going to yield them back one after another. But this sequence to list actually turns it into a list in memory. So then it becomes a list, and all the values are there. If we make this very large, and we just print out B, we'll see that it just shows you the first little bit. But if we turn this into a list, now this is the interactive is only going to print so much of it. It doesn't want to print forever. This could be quite huge. So that's what a sequence is in general. We'll be touching a little bit more on sequences later. I wanted to point that out, though, mainly that a string is just a sequence of characters. So let's save that, and let's go take a look at our password file. So these are our password rules. The next part of it that we want to talk about is min lowercase, min uppercase, and min digits and min specials. And how are we going to approach that? Well, I have some lists here that I created. Let me bring those over. And these lists use a list mechanism for creating lists that's called a range. This is this creates a range from A to Z. This is from capital A to capital Z, 0 to 9. And then list module with a capital L has a function called concat, which is convenient. Now, I used concat for this. This could be done differently. There's a variety. There's always multiple paths to do things. In this case, I created a range of these special symbols, and as you may know from the ASCII chart, they're broken up into different areas. They're not in a single range of numbers. So this range is these symbols, this range is these symbols, and so forth. And these are lists, each of which is an element of a list, which is this outer list. And what list concat does is combine those all into a single list of special characters. Now, what we want to do is find a way to compare what we have in one list to what we have in another list and count them. So I've got a function here we're going to write, and we're going to call it count elements. And we're going to have list 1 and list 2. And all this is going to do is return back the number of elements in list 1 that exist in list 2. So it's going to be, got a loop, so it's going to be a recursive function. We're going to call this counter L1, L2, and count equals. And we're going to match list 1 with, well, if it's an empty list, we're just going to return our count. Otherwise, if it's got a head and or a tail, we'll call it rest. Now we're going to do something with this. We're going to call if list, and this is the list module, contains head in list 2. Now what's this saying? We'll put the then down here. Then. So what's this asking? It's looking at the head of list 1, which is, if we're on the first iteration, it's the first character in our password. And it's looking to see if list 2 contains that head. If it does, if that head is in whatever this second list is, then what we're going to do is call our recursive function counter with the rest of our password, or whatever it is, whatever list it is that we're looking at. We're going to pass in our L2 again, and then we're going to say count plus 1. And what that's going to do is that's going to increment this counter. Remember, we're always working with, as much as possible anyway, with immutable values. So count is immutable. We can't just change count or increment it. We're going to pass in, by calling it recursively a second time, count plus 1. Otherwise, if it's not in the list, else counter rest L2 and just count. We're not going to increment the count. Now what's that going to do? So if it's not in the list, then we're just going to keep the count as it was and continue on looking at the next character in the password. And to kick this off, we need to call counter list 1, list 2, and start our count at 0. Okay, so let's check this out. Let's see what happens here. We'll pull these in to our interactive, and let's try something. Let's say let count elements, let count equal count elements. And for a password in list 1, we'll pass in. Well, actually, it needs to be a list. So we're going to go sequence dot to list, and we'll do password. And for the next list, we'll pass in lowercase, and count in that case equals 8. If we make this password, it only equals 4. So it's only counting the lowercase characters. If we make this special, there aren't any, so count will be 0. So it didn't find any specials. Let's put in a special character, and now count equals 1. So we're able to count how many of each one of these is in a password. Now what do we need to do to use that? So we've got our functions here. Let's create a new function, and let's make it check lowercase. Let check lowercase. And some password, we've got rules, so we've got to pass in rules. And password, we'll go ahead and tell it it's a string. That'll just make things a little easier to start. At some point we may be able to eliminate some of these types that we add here, but every once in a while we run into problems with the not knowing what type it is. So what do we want to do with our password for check lowercase? Well, we want to let's do it simply. Let's count equal count elements. Shoot. Did not want that. Count elements. we're going to have to turn that into a list. Password and lowercase. And then we can, if count is greater than or equal to rules dot min lower, what's it called exactly? Min lowercase. Then password pipe through succeed. Oh, we didn't create succeed. Let's do a couple other things here. Let's do one other thing real quick in result. Where's our result module? There it is. I have added a few other functions into this. I'll go over them. We've got a succeed and fail function in here. I don't know if I showed those to you. Basically, they are constructors for success and failure. And when you call succeed, it just turns whatever X is into a success X up here. And whenever you call fail X, it turns it into a failure X. So just to be clear on that. And I'm not sure why it didn't like that. Let's put this down here, and then else fail, and we'll do an sprintf password must contain at least %d lower case characters. That's right. And this will be rules dot min lowercase. And I'm going to take this fail and I'm going to put it at the end here with a pipe through fail. That saves me from having to do parentheses, right? This is the nice thing about these operators, especially this pipe forward operator. It takes everything, it takes the result of this and puts the result, which is what we want, in front of fail. Otherwise, to do it the other way, like I had it with fail sprintf, we'd have to put all of sprintf and all of this in parentheses, and that's just a little harder to read. So that pipes through fail. So now we're returning a success or a failure based upon this rule. We've turned the password into a list, and we've got our lowercase check. So we can test that now. Did we ever create anything to test it? This is so what I'm going to do is go up here into module 3. I'm going to add a new project. F#.NET Core console application. I will just call it the test console. Actually, you know what? I think we should create an NUnit test project and go ahead and do some NUnit testing on these rules. I think that'd be a good idea. Let's create we'll call this business rules unit tests. And so we have an NUnit testing framework now. That's namespace is fine. We're going to have to open some things. First of all, I'm going to build this business rules unit test. I'm going to build this one. Make sure it builds. Good. We need to reference it. We need to reference our project that we want to test. So utilities. Is it utilities? Yes, it is. So we've got a reference for that. Now we're going to need to open some open F# dot utilities dot result and dot password. So we can set up our password test. So here's our test class. Let's call this. We'll call this this first class here. We'll call it password rule tests. And we've got our setup function, which we will not use just now. Well, yeah, we can. Why does the test class have a problem? I'm going to change this to password rule tests because I just like to keep things organized and know what file is what. And why is this having a problem? Oh, I know why. So this is apparently something that happened. I ran into this before. You might run into it. Apparently the template is a little out of date with the latest NUnit stuff, and it's no longer test class. It's now called test fixture, setup and tests. So here's our tests. So yeah, in the setup, let's do something here. By the way, this is how you create a class in F#. It's a type. This is any constructor values you want to pass into it. And then you can use those in here. We're not going to pass anything into the constructor for now, and we're just going to use this very simply. I'm going to create a member here, member, and it's going to be mutable rules equals, no, it doesn't need to be mutable. We'll just make it what it is. Member this dot rules. They've used this throughout. You can use, by the way, when you're creating a class, this here is the pointer to whatever this object is. It doesn't have to be this. It could be X. We could go change all these to X. And it would accept that. Now X is our pointer within to our object instead of this. But to keep consistent with C# and other languages, I personally like to use this. Don't know what happened there. The rules equals. We'll create our record type. We'll say min length equals 8 semicolon. It should recognize them now. Max. We've got our password being loaded in. Min length, max length. I'm just going to copy these and we'll edit them. Min length equals, we'll say 8. Max length equals, we'll say 16. Min lowercase, we'll say equals, we'll just set them to 1 for now. We want at least one of these in here. I'm not sure why we're getting all these red lines. Maybe it's because it's not edited. There it is. So now we have our rules. We don't even have to call setup for that. This will just be set up for us. So let's make our first test. Let's do password password contains min lower case. I'm going to try something here. So we have our password contains min lowercase. All we have to do is call, what's our function? Well, let's create a password first. Let password equal, and then we can do match check lowercase password with, and for success, we don't care. When you're doing pattern matching, if you put an underscore, it means you don't care what the value of the success was, and we're just going to say assert dot pass failure, don't care, assert dot fail. We'll do it very simply for the moment. Oh, we got to pass in the rules. There we go. This dot rules. There we go, because it's a member. Okay. Okay, we got it. Let's compile our test framework and go take a look at Window, Test Explorer. I hope you can see this okay. There's our test, business rules test. Let's run it. Run selected test. And there, it passed. If we want to see it fail, we run it again. It should fail. And it did. So let's put this back to something that passes. At least passes that test. And there it passes. It's got at least one lowercase character. Now, we can refactor this at some point so that we're using some of the tools that we've developed so far. But for the moment, let's just continue on and build our tests. So the rest of the tests are going to be identical to that one, with the exception of which one of these is used and which one of these rules is looked at to determine it. So we could actually build a more abstract function out of this that lets us pass in the rule and the list and so forth and get back. But for the moment, we'll do it the simple way and we'll refactor later. So let's just copy this here. Oops. And we'll make it check uppercase. Uppercase. Change this to uppercase. Dot min rules dot min uppercase. Password must contain at least %d uppercase, and min dot uppercase. And that's it. We now have those two rules. So let's compile that. Let's go back to our testing framework. Where is it? And it's going to be basically the same test, right? Except we're going to call a different function. So check uppercase. Uppercase password contains min uppercase characters. And assert pass or fail. Let's do a build. And here's our next one. Let's run it. And there it is. Passes the test. Now we can do this with a whole bunch of actual feed in a bunch of different passwords to it, but I think it's pretty obvious that that's passing that test with no problems. Okay, and it's time for another coding challenge. What I'd like you to do for this coding challenge is implement the next two rules, the digits and the special characters, and create unit tests for them. We'll build them ourselves when we come back and have fun with the coding challenge. See what you can do, and if you want to add a little extra challenge to it, make the functions a little bit different. Use a different method for running the tests and running the actual checks. So pause the video here, and I'll see you back in just a moment. Okay, welcome back from the coding challenge. I hope you enjoyed yourself and did well. Now let's go ahead and implement the code, and you can compare what you did to the way I do it. And remember, There's no one right way to do things. There are better ways, there are worse ways. In many ways, I'm just taking a very simple path that's easy to explain and hopefully easy to understand. This check digit, check digits, and we'll copy it again, make it check special. So for digits, this is going to be D-I-G-I-T, digits dot min digits least blank digit characters and rules dot min digits. And real quick, this one will be special rules dot min special at least the special characters rules dot min special. Build that. Oops. And then go over to here, and we'll quick do 2 more of these tests. Min digit characters, min special characters, and so check oh, it is digits, okay, and this one here is going to be check special. There we go. 2 more tests. Build it. Let's go back to our test explorer, run all, hopefully compiled. Contains special characters, because it doesn't contain any special characters. There we go. All our tests are passing. Now we can make these tests more robust. These aren't the greatest of unit tests, but it gives you some idea of what you can do here with a testing framework. And we'll make better tests as we move along, and we'll actually even make better functions to do this stuff by factoring some of this stuff out into a single function, and where we're just passing in what it needs to know in order to run the test and get a reasonable result back. And there's a variety of ways that can be done. But so we've got these taken care of, uppercase, lowercase digits, and special characters. We want to make sure it does not contain white space, and it's neither null or empty. I think we already took care of null or empty. Yep, it's not null or empty, and the password length. And really the only one we have left to do of these rules is does not contain white space. We really should make a test for password length and is not null or empty. And we really should have tests, negative tests as well, tests that show that it detects that the rule is failing as well, and the test succeeds when the rule fails. And we can build those all out as time goes by here. Yeah, the basic set of rules, really, the white space one does not contain white space. So that's actually a fairly simple check we can do. And let's see, let's do it after. So I'm winging it because I did not plan this one. Did I do a white? So let me see. Did I do a white space check? Check white space. Here it is. Oh, and I used a regex. Oh, okay, it's a simple regex. So password contain contains no. Let's do check password for white space. Password equals. So now we're going to use a regular expression. So we're going to say we'll just call it regex equal new system dot text dot regular expressions dot regex. Now what we can do is open this namespace right here. Let's go up and do that right now. Oops, I've got to put open. And then we don't need that. Now what's the regular expression we're going to use? We'll put an @ sign in front of it, tells it, just like in C#, to ignore things like this backslant S. And then what we'll do is, so that's going to check for any, so we'll go match regex dot is match password with, actually we'll do this. Okay, so if it does match, we'll say fail. We'll say password must not contain white space. Pipe through fail. And if it's false, we'll say password pipe through succeed. So let's build that. Let me close these up. And we'll go over to our tests and we'll make another test. We'll just grab this one. Password contains no white space. And what we'll do is we'll make it contain some white space. Let's say check white space. And this one doesn't need a rule, it only needs the password. And this one should fail because it's got white space in it. In fact, let's build it. Let's run that test. And it did in fact fail. Let's take the white space out and run it. And there it is. That passes. So now we've got the ability to test for white space. Let's check our requirements. It's not null or empty. It contains no white space. We can test that. Configurable number of upper, lower digits, and special characters. So it looks like these are generally meeting all of our requirements. One last thing I want to do is create a function that checks all of these. Password is not null, needs to get tested first, and if it fails, everything else does not get done. The rest of them doesn't really matter the order, but password is not null needs to be first. So let's say let combined password tests checks rules password equal, and we're going to take the password and pipe it into each of these, well, to this function. We want to check first, password is not null. 2, password is not null, and that's fine. And then what we're going to do is use our bind operator for password check password length, and we'll pass in the rules, and then we'll bind it to, I should have named these better. I made that password length and then I made it check. So I probably should rename this to check password length. And then we've got all the rest of them are checks. So we'll make this check password length, check combined with check lowercase rules combined with check uppercase rules combined with check digits rules combined with check special rules. So what does this do? This chains together all of these functions we've created into a single function, such that if any one of them fails, the rest of them are not called. And this is the equivalent of calling password if password is not null, then check password length, if check password length, then if check, and so forth. The chain of if statements. This eliminates that chain of if statements and gives us a pipeline, and that's why one of the reasons why this result of success and failure is so powerful. We can chain these together, and the very first one that fails will skip all the rest. Now that's not so important with these as it is with this one. If password is null, we don't want to run any of these other checks because we would get exceptions. So this acts as a guard. We're going to rearrange this later in another lecture such that we can actually collect all of the failures here except for the password is not null. If that fails, we won't do anything else. But if we get any into this section here, we will be able to collect all of the failures at once from a single pass. So let's build that and test it. And now we'll have to build a password that meets all of the rules to test this. And we'll do 2 tests in this case. We'll do a negative test first. We'll see that it fails something. So we'll call it combined password rules. And so if password is null, we'll go combined password checks rules password, this dot rules. There we go. If it's null, it should fail. Now in this case, I'm going to collect this F and I'm going to put it here. And this should fail with a null. Let's build it. And here's our combined password rules. We'll run it. And it failed. And do we get a message? Password must not be null or empty. Okay, so that's good. If we make it empty and run it again, still password must not be null or empty. So if we put a single character in it now, run the selected test, password length must be greater than 8 and less than 16. So it's got to be at least 8. So now we're at least 8. We run the selected test. So you can see it's running all of these different rules one after another. Password must contain at least one uppercase character. Okay, so let's add an uppercase character. And it must contain at least one digit. So let's add a digit. Run selected test. Must contain at least one special character. Let's add a bang to the end. Run selected test. And it passed. So it passed all the tests. And there you go. So we're well on our way to putting together our password rules and understanding some things about them. In the next lecture or so, we're going to add some additional capabilities here to our result. And that's these functions, and I'll go over these functions. I've already put them in, but I'll explain them in much more detail. We haven't used any of them yet, except this succeed and fail. We touched upon those. So that's it for this lecture. Thanks for watching. I hope you got something out of it, enjoyed yourself. Be sure to get on the forum and ask questions and post some code up there. If you have any questions about anything, feel free to ask. And we'll see you in the next lecture.